Something really cool just happened in Japan. On October 3rd, 2025, they turned on a brand new power plant in a city called Fukuoka. But this isn't just any power plant. It's Asia's very first commercial osmotic power plant. Now, I know what you're thinking. Osmotic power? What is that? It's a totally new way to think about renewable energy, and it could be a massive deal for our planet. This plant is only the second one like it in the whole world, with the first one opening in Denmark back in 2023. This new facility in Japan is even bigger and is being run by some really smart people at the Seawater Desalination Center and the Fukuoka Area Waterworks Agency. It's all about finding solutions that work with nature, not against it. So why does this one plant matter so much? Well, we're all looking for ways to fight climate change, right? We need clean energy that doesn't pollute our air or warm our planet. This plant is a huge step in that direction. It's expected to generate around 880,000 kilowatt hours of electricity every year. That's enough clean energy to power about 220 homes, which is awesome. A lot of that power will actually be used to help run the desalination facility right next door, making the whole system more sustainable. Kenji Hirakawa, the director of the center, called it a meaningful plan against climate change and a stable source of electricity generation. It's these kinds of innovative ideas that get me so excited about the future. The location in Fukuoka is no accident. The city is a hub for innovation, especially when it comes to water. They already have a facility that turns seawater into fresh drinking water, which is a process called desalination. This new osmotic power plant is cleverly connected to it, which we'll get into later. For now, just imagine the incredible potential. We're talking about a new source of renewable energy that's not just a science experiment anymore. It's a real working power plant providing electricity for a community. It represents a shift in how we think about our resources, especially the incredible power hidden in water. This event isn't just big news for Japan, it's a beacon of hope for all of Asia and the world. As countries everywhere look for reliable alternatives to fossil fuels, a project like this shows what's possible when we invest in new technologies. It proves that we can find energy in the most unexpected places. Professor Akihiko Tanioka, an expert from the Institute of Science Tokyo, said he hopes this technology will spread globally. And I'm right there with him. Seeing a country like Japan lead the way with such a forward-thinking project is truly inspiring and makes me believe we're on the right track to a healthier planet. Okay, so how does this thing actually work? It sounds complicated, but the basic idea is surprisingly simple and comes straight from nature. It's all based on a process called osmosis. You might have heard about it in a science class. It's the natural tendency of water to move from a less salty area to a more salty area when they're separated by a special filter or a semi-permeable membrane. Think of it like this. Nature always wants to find balance. If you have fresh water on one side and salty water on the other, the fresh water will naturally flow through the membrane to try and dilute the salt water. This plant, which uses a method called pressure-retarded osmosis, harnesses that natural movement. Inside the facility, they have these advanced membranes. On one side, they put fresh water, which could be treated wastewater. On the other side, they have super concentrated seawater. Because of the huge difference in saltiness, the fresh water is pulled with incredible force across the membrane into the saltwater side. This rush of water dramatically increases the pressure in the saltwater chamber. It's like blowing up a balloon, but with water pressure instead of air. That built-up pressure is pure, raw power just waiting to be used. Once that pressure is built up, the next step is pretty straightforward and similar to how other power plants work. The highly pressurized water is directed through pipes to spin a turbine. You know, those giant fan-like things. As the turbine spins at high speed, it drives a generator and voila, electricity is created. It's an amazing and elegant way to convert a natural chemical process into clean, usable electrical energy. It's all about harnessing a fundamental force of nature that happens every single day, everywhere water, with different salt levels, meets. The real genius is figuring out how to capture that energy on a large scale. What makes the Fukuoka plant extra special is how it gets its salt water. It's connected to a desalination plant next door. Desalination creates fresh water from the sea, but it also produces a waste product, a super salty leftover liquid called brine. Normally, getting rid of this brine is a challenge, but here they use it as their saltwater source. This concentrated brine has a much higher salinity than regular seawater, which means the osmotic pressure is even greater. Professor Sandra Kentish from the University of Melbourne pointed out that this is a huge advantage because it increases the amount of energy you can get. It's a perfect example of synergy, turning waste from one process into fuel for another. When we talk about renewable energy, we usually think of solar panels and wind turbines. And don't get me wrong, those technologies are amazing and super important. But they have one big challenge. They are intermittent. That means they only work when the conditions are right. Solar panels need sunshine, so they don't generate power at night or on cloudy days. Wind turbines need wind, so they're useless on a calm day. This can make it tricky for the people managing our power grids, because they need a steady, reliable supply of electricity to keep our lights on. They need what's called baseload power. This is where osmotic power really shines. Its biggest advantage is its consistency. The process of osmosis doesn't depend on the weather or the time of day. As long as you have a steady supply of fresh water and salt water, the plant can run 24 hours a day, 7 days a week, 365 days a year. This makes it an incredibly reliable source of baseload power. It provides a constant, predictable stream of electricity that can stabilize the entire energy grid. The Fukuoka plant, for example, is expected to generate an amount of power comparable to 2 soccer fields covered in solar panels, but it does so around the clock, without interruption. This reliability is a total game changer. Imagine a world where our clean energy sources aren't just for when the sun is out. With osmotic power, we can have a foundation of clean energy that's always on, supporting the grid while solar and wind contribute whenever they can. This combination makes our transition to 100% renewable energy much more realistic. We wouldn't have to rely as much on massive, expensive batteries to store energy for when our intermittent sources aren't working. Osmotic power plants could fill that gap perfectly, providing the stability we need for a clean energy future. Of course, this technology has faced its own set of challenges. The idea has been around for a while. A Norwegian company called Statkraft built a small prototype back in 2009, but it was difficult to scale up because the membranes weren't efficient enough, and the costs were too high. There were also issues with energy being lost when pumping the water, and with the membranes getting clogged up, a problem known as fouling. But technology has come a long way since then. The new membranes are much more efficient, and clever designs, like using waste brine in Fukuoka, are making the whole process more powerful and economically viable. The journey of osmotic power shows that great ideas sometimes need time to mature. The early projects in places like Norway were crucial for proving the concept, but they hit roadblocks that seemed too big to overcome at the time. The cost of the membranes and the relatively low energy output made it hard to compete with other energy sources. For a while, it seemed like osmotic power might just remain a cool idea in a textbook. But dedicated scientists and engineers around the world kept working on it, improving the technology piece by piece. Now, with the launch of commercial plants in Denmark and Japan, we are seeing those years of hard work finally pay off. What has changed is a combination of better technology and smarter thinking. The membranes are now more durable and allow water to pass through much more efficiently, which means more power. And the idea of integrating these plants with desalination facilities is a masterstroke. It solves 2 problems at once. It gets rid of the waste brine from desalination while simultaneously boosting the power output of the osmotic plant. This kind of thinking, where we create systems that feed into each other, is exactly what we need for a sustainable future. It's about building a circular economy where there is no such thing as waste. The potential here is absolutely mind-blowing. Scientists estimate that the energy released globally, where rivers meet the sea, is around 30,000 terawatt-hours annually. To put that in perspective, that's more than the entire world's current electricity demand. Of course, we can't capture all of it, but even tapping into a fraction of that could be revolutionary. Some projections suggest that by 2050, osmotic power could meet 15 to 20% of the world's energy needs if we continue to overcome the technical hurdles. The Fukuoka plant may seem small, but it's a critical proof of concept that can inspire similar projects all over the globe, especially in coastal areas and river deltas. So, this small plant in Fukuoka is much more than just a local success story. It's a symbol of human ingenuity and our determination to find better ways to live on this planet. It's a testament to the idea that sometimes the most powerful solutions are hidden in the simple, natural processes happening all around us. Seeing this technology come to life gives me so much hope. It starts with one plant, then another, and soon it could become a key part of our global clean energy mix. This is how big change happens. One brilliant, bold step at a time. It's a new wave of energy, and it's just getting started.